Hello. Today I have Zodiac Project Sagittarius by Maze Gator. I think this is the first Maze Gator puzzle I've ever actually done. So I'm pretty excited about that. And I'm also excited about the Zodiac Project series in general. And I love the name and theming of this. I mean, these arrows are just very evocative, I think, especially with these little crosses here. You can really see the bow and the arrows going through here. And I wondered after Kristinette's Gemini if we were going to start getting more zodiac names, and it seems we are, which I also enjoy. I think the very first puzzle was Orion or Orion's Belt, and we're finally getting back to basics here on the naming at least. So, what are the rules of this puzzle? We've got irregular region Sudoku. So that means is instead of 3x3 boxes like we normally have, we're going to be placing the digits 1 to 9 in every region, which are outlined in green borders in this case. So each of these regions that are marked off here are going to have the digits 1 to 9 once each. And as usual, we'll have also rows and columns, digits 1 to 9 once each. We're going to have arrows. So this arrow, for example, is going to be some number. Like let's say this is let's say it's an 8. Then these three digits here will sum to 8. So the digit in the circle will sum to the value of all the digits on the arrow. So this could be, say, 1, 2, 5, or 1, 3, 4, or any shuffling of those digits to make 8. We have Renbans, which are these pink lines, which means since they're only length 2 here, each of these pink lines is going to have a set of consecutive digits. And then we have the rule that is kind of the basis for this Zodiac project, which is this disjoint set of circles. So all of the projects have basically someone sets a puzzle with a disjoint set. So each of these circles represents a disjoint set, or each of these circles represents one of the digits 1 to 9 without repeats. There's 9 circles here. So each digit will be represented exactly once. And then once you make the puzzle, you craft a new set of 9 circles, a new placement of circles, and you hand it to the next setter, like a chain letter, and they have to set their own puzzle with the 9 circles you give them, and then they change the circles and so on and so forth. Anyway, that is the premise, and those are the rules. So let's go ahead and see what we can do. I think it makes sense to start with the disjoint set. Are there any arrows? Like, how many arrows can be that big? I mean, a lot of them are just 2. Actually, almost all of them are just 2. Oh, it's this arrow. This arrow is so long, it didn't even strike my mind as an arrow as I was scanning. Yeah, so this arrow is clearly, it's 6 digits long. So this is, I mean, the problem is they could literally all be ones here. But so this is 6 to 9 somehow. So these digits are, I mean, I guess they're only 1 to 4, which is not actually that, which is actually not that constrained. I wonder if there's a problem if they're literally all 1. If they're like, can I get rid of 6? Can these literally all be 1? No, they can't all be 1 because then none of the circles. Right, so one of these circles has to be 1 because the digits 1 to 9 are in all of these circles. So one of these is a 1. If these are all 1, then at first I thought we could put a 1 here, but this is one of the few arrows that actually has 2 digits on it. So you can't put a 1 here. You can't put a 1 here, right? Not on all of these arrows. So the rest of the ones, if those are all 1s, I mean, easier way to see it is, where does the 1 go in this box? It's here. Where does the 1 go? It's one of these 2, but it can't go here because that would repeat here and break that. So we get a 1 here. We get a 1 here. None of those are on circles. So these can't all be 1. So this can't actually be 6. And I wonder if we could do something similar where, like, can we rule 1 out of any of these digits because they would break? Or can I rule 1 out of here, for example, Yeah, because if this is a 1, maybe I can figure out which arrow 1 goes in, which circle. Because if this is a 1, none of these are 1, right? This sees these 2, and this sees these 2. So these are all at least 2, which is already 8, 9, 10. It's too big. So maybe I can start coloring, and obviously circles with arrows bigger than 1. So I'm going to color red for a second. This one might be okay, actually, because these could not be 1. Oh, no, this one couldn't be 1 either because it's in the same region. So we get 4 cells that can't be 1. Those are at least 2. It's 8, 9, 10. That one doesn't work. This one I think is more straightforward. So that one's not 1, which I think means these are 1. Right? That's all the possibilities. So that's a 1. Those are both 1s. And I can get rid of that coloring. And now this digit is at least 2, which is not that exciting, except that means these now can only be as high as 3. Because if I do 3, 2, that's already 5. 6, 7, 8, 9 is as big as I can go. Oh, and this one looks at this circle. So that is now a 9, because the minimum I can make this is 2, 3, 4. So that's what it must be. And this 2, 3, 4 is in the same region as here. So I get another 1 here. And now can I do more with 1s? Just like basic Sudoku stuff. Probably not. But now this isn't 9. So these aren't 3 and this isn't 4. Which is going to be helpful. Oh, and now I get a thing where if any of these are 2, this becomes a 2 as well. So I wonder if I can pair any of these off. Like if this is a 2, I have to minimize the line. I essentially have 1 degree of freedom on this line because the most it can be is 8. So if I make this 2, I'm stuck with 1, 1, 1, 1. That's 4, 6, 8 is the minimum I can do on the arrow and the maximum I can do on the circle. So so if these are both 2, can I say that none of the circles then work? Yeah, I think that's right. If these are not, let me just make sure. If these are both 2, then this circle can't be 2 because it sees this. This circle can't be 2 because these both have to be 1, but these would be 1. This circle can't be 2 directly. This circle can't be 2 directly because it's here. Same with this one. This one would need 2 1s, but I already have a 1 here. Yeah, so actually this is a 1 as well. How about this one? 2's here. This one's gone, this one's gone, this one's gone, this one's gone. This one is gone because if this is 2, we would need a 1 here, which it can't be. And this one can't be 2. Yeah, so this is a 1 as well. Can I just go up the line doing this? If these are both 2, still not this one. It's definitely not this one. This one already can't be 2 no matter what is going on here. This can't be 2. Hold on, let's make it simpler. What can be 2? Not this, not this. This possibly, not this because that would put 1s here. So these are my only possible 2s. So these are the only ones I need to worry about. So if these are both 2, that gets rid of it from here and here because this cell sees here and this one. So this is a 1. If these are both 2, yeah, no. Oh my goodness, it's so much easier. This is just a 3. Sorry. This is a 3 because if this were a 2, it would just already... Maybe I needed to do some of these though first. Like, could I have rolled? I think so. Yeah, I mean, if this were a 3, no, sorry, if this were a 2, oh no, then I could have put a 2 down here. So I wonder if I had to do that first anyway. But anyway, now this, whether I could have done that earlier or not, this can no longer be a 2 because if this is a 2, this sees this cell, and this cell, which all correspond to either a circle or a 1-digit arrow, which means these are the same digit. So this can't be 2. So this has to be a 3, and that's now a 1. And I can probably finish 1s. Because where does 1 go in this row? It's here. And then my 1s that are left, this should be all, I should have 1 left, it's right there. So ones are done. Let's get rid of this orange because that was about twos. Well, maybe keep it actually, because I am going to need to know. I'm going to need to find a two eventually. But with all these ones gone, well, this now is at least 4. Is that interesting? I'm not sure it is. This is a 2, 3, 4 triple actually, because these digits look in here. That's a 2, 3, 4 triple. I'm not going to mark that that's 5 to 8, although it is. This isn't 3 at least. Can I do more with 3? I keep wanting to put 3 in this region here, but the 3 in this region's up here. Oh, and now I can follow this along actually. Where did 2, 3, 4 go in this region? Unfortunately, I think they can go, one of them could go here. I was thinking they had to go here, but I think I could put 1 here. I can't put 2 here. And in fact, okay, let's back up a step. This cell, where does this go in this region? Because it sees all of those by Sudoku. It sees this by being on the same Renban. These can't be the same digit because they have to be consecutive. So this digit goes in one of these spots, which can't be 2, 3, or 4. So this is at least 5, which means this is at least 4. So 2 and 3 definitely go in these cells. And 3 doesn't look in here. So that's a 3. Therefore, that's a 2. And now where does 2 go in this region? Not here, because that can't be consecutive with 3. So it must go here. And now this 2 sees these orange cells. So these are both 2, which we'll put a 2 here as well. And we're done with, no, wait, we're not done with 2s. We're getting there though. That's 4, that's 3, that's 2. 2 in this region must be done. Yeah, it's right here. 4, 7. I have two 2s left. They're here. And I don't think I can distinguish them yet. It's got to do with this arrow, but no, not sure. So now this is 5 to 8 only. This is at least, these are at least 3. So this is at least 6. So hold on. 1, 9, 2, 5, 6. Oh, 3. I was like, I didn't see this one. And I was wondering, I thought I had too many digits for the circles because I couldn't see this one. So one of these is a 4. So one of these is a 4, actually. One of these is a 4. One of these is a 4. This can't be 2 or 3. So actually this is at least 4. So this can't be 5 as well. So this is 6, 7, 8 triple, which means these are all 4, 5 pairs. So that's not 5 anymore, which means this isn't 4 anymore. And now 4 has to go here. And now that already isn't 5. Yeah, this is I'm really enjoying this. Where? No, I keep every time I look here, I think this goes here, but it's up here. These are from 3 to 5. So this is 3 or 4 only. I get a 3, 4 pair in the column. This is 3 or 5 only. Yes. 2s are done except to here. Is there any way this isn't a 2? I think that's possible. We could do 3, 4. This is only 4 to 6, so I'll mark that. One of these is a 6, which is not that exciting. Okay, this can't be 3 because I would need to put a 4, because all the 2s are gone except for here. So all these digits none of the red band lines can have 2s on them. And then therefore, and I can't put 3s on any of them either because, right, hold on, if this is a 2, no, I know it can't be 2. If there's a 3 here, this can't be 2, so it'd have to be 4, but it can't be 4. Same this way. 4s are looking right at this Renban. So since there's no 4, there's no 3. Since there's no 4 and no 2, there's no 3. See, this one can't be a 3, 4 Renban, and it can't have a 2, so this also can't have a 3. But I think this could be 4, 5. No, it can't be 4, 5 because there's no 5. So there's no 3 in this Renban, there's no 5 in this Renban. So these are definitely from 6 plus, which I will now mark. And since I don't have any digits 6 or higher, I can't do more than that. But that is, I wonder if I can do the same thing here. These can't be 3, they can't be 4. So these are 5 plus. Could this be a 5-6 Renban? I think the answer is yes, unfortunately. Well, this one can't be 5. So if it's 5, 6, so this one is at least is 6 plus, because this is in the same region as this 5. Oh, hold on, this 5 looks in here and gives me a 5 here in this region. Oh, this 5 looks right here. That's a 3. So this now can't be 8 anymore. This 3 looks up here. 4, 3 gives me a 4 here. That's now 7, which makes this 8, and this 6, which means this is 4, 2. It's minimized. That finishes 2s. So 1s and 2s are done. And I have all, my disjoint set is done. So now we should be basically done, I think. This can't be 9 anymore because that would make this an 8, which it can't be. Okay, let's be systematic. How about 3s? 3s in this region are not restricted at all. 3s in this region, one goes here. 3s in this region goes here. It can't go here because of the Renban. Let's see, it's one of the, no, this region's now done. It's there. This region is here, and this column is there. Is that a 1, 2, 3, 4, 5, 6, 7, 8, 9? Yeah, that's it. 3s are done. 4s. Those 2. These 3. Like I said, I think I can X-wing here in the rows. I don't think it's, oh no, there's a 4 right here, sorry. Is that 1, 2, 3, 4, 5, 6? I should have a 4 given now, this one. So that's a 4. And I will mark these like that. This can't be 9 either because I would make this 8. These can't be 7, which means these can't be 6. So they are an 8, 9 pair, which means these 3 digits are 5, 6, and 7. 5's not here, sorry. Can I do 5s? No, let's go to 4s first. 4. Oh, I already did that. These are 4s. All right, then we are on to 5s. 5s. These 3. These 4. These 3. These 2, which means it's not here. These 2. Oh, 5 in this column. Oh no, it could go here. Shoot, now I erased all my marking. Okay, yeah. I don't think that's the way. You have 5 here. Yeah, no. This is not 6. This is not 6 or 8 actually, so it's odd, which means this is even. In fact, this is an odd triple, so this is a 9. I have the 6, 7 pair in the column, so I knew that was a 9. This 7 looks down here, so that's 5, which makes this 6. That's 7. I still don't know anything about this. 7 looks here, sorry. I find it hard to scan a little bit with all the colors here, but that's just a me problem. These are from 5, 8, and 9. I don't see any way. This is from 6, 8, 9. Let's see, these are from 7, 8, 9. That's not 9. All right, let's just try 6s. 6s now one of these, and therefore one of these. So I get this box of 6s here. And then in this box, that means my 6, oh, it's one of these. Well, this is now from 5, 6, or 9, because 7, 8 are gone. One of these is a 5. All of these still work. Okay. This can't be 5. This can't be 5. What is this digit? Where is this digit in this box? Can I limit it further than here? I don't think so. These are from 6, 8, 9. This one's not 6. So I can 8, 9 pair here. So this one's 6. Which means 6 in this box goes here, which means that's 7. Oops. That's now 9 and 5. And hopefully we're getting close. These are not 4 or 6. This is 8 or 9 as well. So I can 8. Why can't this be 6? Here. This can't be 4 or 6. So we have an 8, 9 pair in the column, which means this is a 5. These are from 6 and 8. And I don't know, but I should know this one will be 9. These digits will be 7 and 8. Still unknown, which means that this pair is also 7, 8. So these are going to be the same. Which is not helpful at all. I need a 5 somewhere. Oh, no, 5 in this column has to go here. There's definitely a 9 here with 7 and 8. Well, this digit is this digit. Does that help? Should I start coloring 8s and 9s? I'm gonna hold off for a little bit. See if I can. One of these is a 5. Oh, 5 goes here in the column. Let's see if I can finish 5s. 1, 2, 3, 4, 5, 6, 7, 8. I should be able to finish 5s. No, there's no 5 in the top row. I messed up. I must have mismarked something. There's no 9 here. Those could all be 5. But that means that 5. Hold on. Hopefully there weren't other. Where did I put 5s? And that's fine. Okay. Nothing else I did, I don't think. Well, maybe that one. Okay, so let's go back. These are 5, 6, 7, 8, not 6, 7, 8, 9. So that 5 deduction might have been bad. No, because this came from this. Where does 5 go? In the row, which is correct. So I get a 5 here. These are from 7, 8, 9. I need a 5 here somewhere. So this is a 5, 6 pair, which means that's not a 6. How did I know this wasn't a 5, but why wasn't it a 6? Because if that's really true, that's a 6. Why was this not a 6? I wonder if I mismarked that as well. I had a pencil mark 6 here, which might have been... No, it was because of this 6 gave me here, and then that 6 gave me those. Okay, so that was correct. Or I think it's correct. This is 7, 8 pair, looks down here. 5, 6... No, that's not 9, that's 7. Now I'm probably going to be able to color 8s and 9s, but I'm going to see if I don't have to. 5 in this column now is here, which does a lot of, oh my goodness, yeah, we really have 8s and 9s all over the place. This can't be 7 anymore because this is 7 in the column. I have a 7, 8, 9 triple here, 8, 9 pair, looks at this as a 7, that's a 7. This is 4 with that, but this is going to resolve everything else. 9, 8, 9, 8, 9, 8, 9, 8, 9. Done. Wow. This is rated 3 stars. I don't think it was 3 stars. Maybe the beginning was a little hard, but it was very, very cool. I like the beginning a lot, actually. Anyway, thanks for watching. Thanks for studying this puzzle. I really enjoyed it. And yeah, I'll see you next time.